Hello, everyone. Welcome to today's section on how cloud computing empower collaboration and innovation using open data and shared data. My name is Owen Chong. I'm the Senior Business Development Manager from AWS Hong Kong Public Sector team. So let me start today's section by sharing with you a quote from the Amazon Web Services CEO, Andy Jassy, and it serves as a concise explanation of why the cloud has helped transform so many industries. The AWS cloud allows people to experiment with massive amounts of computing power without needing to invest heavily upfront. And this has given people new freedom to quickly innovate, experiment, and iterate. Jesse's quote also explains why the cloud is becoming so critical to research and data sharing. Just a few years ago, if a researcher had a questions, that could be answered by analyzing 100 terabytes of publicly available data. So the researcher need to find a spare storage capacity to keep all these data. And also, they need to figure out a way to copy these data. Let's assume they have an uninterrupted 50 megabit per second connection. So how long do you think it takes for them to download all these data? More than 6 months, more than half a year. So with that, we see there's a trend happening, the trend of flipping the flow of data. In the past, we used to bring in data to compute. We have a server, we copy the data, download the data, and do the compute. And now what we're seeing is that as the amount of data accumulate, customers have stored it in different silos and making it difficult to do analytics. To make it easier, customers want all of their data in a single repository, which is a data lake. As you see in this slide, Amazon Web Services, Amazon S3 is one of the choices to be a data lake. And by storing the data securely at a low cost using the standard-based data formats of the customer choice, they will be able to analyze their data using ready-made tools available from AWS. So again, this is what we call moving compute to the data. If there are different teams and different researchers that need to analyze and the data on this data lake, all they need to do is spin up EC2 or enable their Athena services, and they will be able to access all these data without downloading them. So this really flipping the flow of data. So when you think of AWS, you might not immediately think of open data. So it is fair to ask, why does AWS care about this? The idea of sharing data started back at least to the 1950s, when the International Council of Scientific Unions established World Data Centers to facilitate sharing of data among scientists. In 1991, Sir Tim Berners-Lee described the World Wide Web as a mechanism to allow information sharing within internationally dispersed teams. The premise behind open data is the best way to get value out of data is to make it available to as many people as possible. Open data policies are also important because they seek to maximize the number of people who can access the data and derive value out of it. It is simple. We care about open data because our customer care about open data. We have many customers who have a mandate to share data publicly, whether they are a government agency, a research institute, or a nonprofit. We also have many customers who are looking to make use of the data at scale to build out new products and services. Let us quickly look at some of the case study. Travel for London, they not only saving more than 130 million pounds per year, but also they enable 600 plus applications serving over 42% of the Londoners. Another case, USGS. The USGS Landsat program provide a remarkable case study in what happened when previously restricted data is opened up. USGS used to charge for access to imagery produced by Landsat Earth observing satellite. In 2008, USGS determined that charging for access to Landsat data was hindering research because scientists simply couldn't afford the charges. Since making Landsat data free and open, its usage has increased dramatically, and the insight from Landsat generated an estimate of 858 million in economic value per year by enhancing analysis of crop quality and informing optimal allocation of irrigation resources. In Farron Institute, a scientist uses the data, open data from NASA, and they reduce their effort and time from downloading and administrating the data and also setting up their own supercomputer. So instead of using 3 months to develop 3,000 lines of code, this scientist can focus on doing the research within 10 minutes and using only 20 lines of code. And the fourth case study is from the researchers of Chan Zuckerberg Initiative. And this case study not only demonstrates how when using cloud, they are able to save money, but also accelerating genomic research. For example, this group of researchers, they need to produce a draft humans assembly, and they are able to complete this in 6 hours using only $70 US. Comparing to the next available tools, which gives them a lot of advantages, doing it a lot faster and less expensive, and which enable them to do a lot more rapid prototyping and parameter exploration, which really translate into a faster innovation. Now, is it that easy to start projects? Actually, no. For every single research, machine learning, analytics projects, 80% of the effort is really spent on data preparation. Not only cleaning up the data, but also in doing a lot of data transformation. And we call this a undifferentiated heavy lifting. No matter what, you need to find a way to resolve this. What we really want to get out of the data is getting the value. And a lot of our customers, they are struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially, coming from new sources, is increasingly diverse, and need to be securely accessed and analyzed by any number of applications and people. The size, complexity, and varied source of data means the same technology and approach that worked in the past don't work anymore. And to support the modern data requirements, we need a cloud data lake, which helps customers to store their data in a single repository and also storing data securely at any scale and at low cost using the standard-based data format of your customer choice. Customer wants the flexibility to analyze the data in a variety of ways, using a broad set of analytic engines, ensuring their needs will be met for their existing and future analytics use cases. Customers also need to go beyond insight from operational reporting on historical data to being able to perform machine learning and real-time analytics to accurately predict future outcomes. And that's the benefit of sharing data using AWS Cloud. Not only you immediately access and be able to support a global community of users, and you'll be able to innovate faster with new services and tools, plus a faster pace and lower cost of research. And that's part of the reason we have the Open Data Program. And this is our mission. We want to drive usage of data by expanding access to it. Our hypothesis is that when more people can access data, more opportunities are created to derive value from it. As AWS can help access and analyze high-quality data at scale, AWS launched the Registry of Open Data on AWS in 2018. Since then, the registry has grown to more than 200 datasets, ranging from geospatial, satellite images, transport data, genomic, COVID, and census data. And the next question, what makes a good data set? How do we make it successful? And in many ways, sharing data is like shipping a software product. Look at the product you are using, like an application on a mobile. It is readily accessible, very easy to use, intuitive. There's also support provided if you don't know how to use it. So preparing a data set, there is a lot of commonalities. For example, data is made up of digital information. That's why it also requires documentation. And it will be used by a group of users who may require support. And it may become vital to others' use work. Another common characteristic of data that is similar to software is that it often gets updated over time as software developers learn from their users and adapt to new technologies. All of this indicate that sharing data is no trivial task. In AWS, we use working backward process to innovate. And when applying working backward process in preparing datasets, it helps us to prepare a purpose-driven dataset. So what is working backward process? It is a process used in AWS to innovate and develop new products and services. We are not saying this is the only way to innovate, but it has been working for us. So how do we start? We always start with the customer and work backwards. So in the case of preparing datasets, what it means is that we always think about how the user is going to use this data. And also we think about how to make it able to access the least amount of data possible to get the answers they needed. So in this way, not only that we're enabling the speed of innovation, but also lowering the cost of analysis. So this working backward process, it is not only being used within AWS or Amazon, we also sharing this with our customer. So if you're interested to learn more, you can contact your AWS representative for more details. Now, after you use the working backward process to prepare your data, the next thing you need to optimize it for analysis. So here are some of the tips. Number one, choose the right method of accessing these data. So the choices are data dump and API. A lot of time, if we know the user how to use it, and we can provide APIs so that they can access and query just the set of data they need. However, if there is chances that user require to download a good lump sum of data, a data dump may be required. So the second point is really ready your data for common analysis use cases. Okay, in this way, you're not only preparing the data for those use cases, you also consider to optimize these data using cloud optimized file format. Now, on top of that, the other thing you will need to consider is to plan your storage structure, how to partition your data, which optimize for query. And the way to do this, we recommend you have a look at the Amazon S3 object storage that really simplify how things can be done when considering you need to partition your data. Finally, you may need to create a map or index of your data that helps user easily identify and locate the data they need. Now you got some quick insights on how to prepare data. And if you want more information, there is a white paper, a 40 pages of very useful information. And here is the link for you to download. Now, hopefully, today's section gives you some more insights on how AWS cloud computing empower collaboration and innovation using open data and shared data. And if you have any open data or shared data initiative in mind, feel free to contact me at this email address. And finally, this is what I want to share with you. Open data is happy data. Thank you, everyone.